One second, I started the record. I'll just start the screen share as well. One second. What I'm going to do from this session onwards, like now, once I'm recording, right, I'm going to upload it directly into the Google the Google Space, because it's going to be 3 GB. I will upload it and then I will start uploading the YouTube also. So if you want to immediately see the session like next day morning and stuff, like now, you can just go and check in that the Google Space I created actually in the. I'll show you. You guys can see my screen, right? Yeah. Yeah, here I will just in this Google Drive, right, I will upload the session, the raw video file itself, and then I will upload in YouTube as well. Once it gets into YouTube properly, right, I will delete it from here because I am allowed to do only 10 GB here. Okay, so that should help. And then the sessions, right, we are going to be keep it interactive. So I mean, if you guys don't have any much noise coming from your side, right, you don't need to keep it in mute actually. So that's fine. Just talk, because it should be. I would like to be as interactive as possible. So don't worry about having noise and everything. So that's the thing. Okay, let's. Yeah, we are going to cover these topics actually. Relational today, what we are going to see is like now. I missed out one data type last week actually, which is string. We will be seeing that today, and then we will see what is scopes also. Apart from those two, right, we will see all these things as well today. Okay, it's pretty simple actually. The thing is like now, all these things will be might look like a trivial information, but down the line, right, for automation purpose, right? Yeah, today I was discussing with one of the session guys, the typecasting, right? You will never really use it the way we did it actually today, because we never really use it in the data types and all those things. But the thing is, down the line in the real automation, when real automation comes, right, typecasting will be used left and right everywhere. So it's really important you guys to understand that one. That's why I covered in the starting itself the typecasting concept. Okay. Yeah, let's meet. Yeah, to do the exercise, right, before starting the sessions, to do the exercise, right, I'm going to cover one topic which will be really useful. So from till, let me open the class. Okay, so say for example, any arithmetic operation, like if you want to do a square of a number, right? How we did last session is like now int val is equal to 5. If I want to square, means int result is equal to val. So this is how we did it actually till last session. Okay, I will print out the result.
Bala,
yeah,
I can't see your screen. It's just. Is it same for everyone?
It is. Yeah, it is, Bala.
You can't see the screen, is it?
No.
Okay, I will stop and share the screen again. How about now?
Gone blank now.
It's blank, so.
Again blank, is it?
Yeah.
Okay.
Yeah, now we can.
Now we can see, is it? Abhijit, how about you?
No, it's still blank for me.
I think that's your internet connection. Something's slow. Maybe downloading something looks like this. Yes, something's not right with your internet connection.
Abhijit, you want to move place or else?
No, it has come up now.
It's come up now, is it? The screen is clear, right?
It's a bit blurry.
What we can do, because it will be your internal connection.
Yes.
You want to move somewhere or else?
Okay. No, it's okay for me. That's fine.
It's okay. Okay. So, okay, yeah. So if I execute this one, right? It's simple as this. Okay, we are all in. What the hell happened here? Okay, sorry. Yeah, if I execute this, right, I'm going to get 25 answers because I'm just finding out square. Okay, so if you want to if you want for another number, you just need to change it out. Okay, now
Sorry, Bala.
Yeah.
So it's not visible on the screen. It's kind of blurry. So I don't. At least I cannot see anything.
so is everyone for everyone it is blurry?
Yeah. It's
Okay.
blurry actually.
Yeah.
Okay, then it might be my internet connection. Okay, once again, I'm just going to disconnect the call and connect again. Okay. Yeah, here. Is it better now or else still the same?
Still dark, like blank.
Can
Yeah, I don't
everyone
see
see my
anything.
face properly?
Yeah, it has come up now, Bala. Yeah. So
Screen. For you, Greg, it is. How is it?
Yeah, I think still there is a problem because I think it's kind of slightly better, but it's still blurry.
it's clear for me, Bala.
Okay. How is it for you, Rajni, Pallavi?
Now I can see only blank screens. I don't see anything.
I can see clear.
Yeah. Now it's coming up. Yeah.
Now it's better. Yeah.
It's better. Okay, 1 second. Just give me 1 minute.
Again, it's gone blurry.
Yeah.
Bala, you want to go back and off your cooker?
Yeah.
That's good. Somebody.
Yeah, I've turned it off. Is it better or still blurry? I didn't want.
Yeah, it's better now.
For everyone, Pallavi, Greg.
Yes.
Yeah, it's much better now.
Oh, okay. Okay, that's fine. Probably turning off the stove helped. Okay, now, okay, what I was trying to say was like, now, okay, till last session, what we saw was like, now, we created a variable, we just, if you want to see the square of the variable, right, we will just do it this way, okay. I'm just going to give you a concept which will help you to get values at the runtime from the user directly, but I'm not going to explain the concept because we are going to see that one down the line actually. Okay, so for doing the exercise, right? Just remember that I'm just going to do that code and then post it in the Google Drive as well. Okay, I will explain to you the code, but we are not going to go deep into it actually because in the later sessions, right? Once we cover the input and output stream, you will know what it is, how it is getting the values from the user. Okay, now let's see that. There is a class called a scanner, okay, which is inbuilt in Java, which is useful to get values directly from the user. Okay, you don't need to do anything. You just need to create an object for that class. Everything or creating an object we will see down the line. Okay, I'm just going to do that code and then I'm just going to give you a bit of a background about it, and then that's the end of it there. Okay. Okay, so now what we have done here is like now we have created a class, we have created an object for this class. Okay, now what I'm going to do is like now say for example you have to specify to the Java what kind of input you want from the user. Okay, say for example here in this place we need integer. Okay, so all we need to do is like now you need just type scanner, the object name, whatever we created here. Okay, it can be anything. You can just do scan1 like this. It's fine, absolutely. Okay, object name can be anything. Okay, you just need to do dot. What you want the int, right? So just read next int. Okay, so what this will do is like now I'm just going to print out. Okay, if I run this, right? Okay, it won't end actually. Usually you will see the program ending, right? It will wait for you. Okay, so now what you have to do is like, now I have to type any value here. Okay, let's say for example if I type a 6, okay, I'm going to get 36. Okay, the same thing actually. Okay, so all you have done is like, now you have got the input at the runtime, and then you just use that value in your program. Okay, that's about it. So if you do any values, okay, you're going to get square. Okay, you can do for anything. Okay, so this is for int, right? So let's do for a float. Okay, float. I'm going to do fval. Okay, so this I'll do is ival. Let's remove all these things. Okay, dot, same thing. There will be something called as next float. Okay, that's it. And then you can do for double also. Everything it will have its own thing actually. Okay, next double. Okay, that's it. Okay, and again here also you can do the typecasting. Okay, say for example you want to get the say, let's do like this. Okay, item. Okay, to scan 1 dot. If you do next float, right, it's going to complain. Okay, so it's going to complain saying that, okay, because it's expecting an int here, but you are trying to store a float. So again you can do the typecasting here if you really want to store like that. Okay, all you have to do is this one. The error will go away. Okay, that's it. It's pretty simple as this one. Okay, and then what shall we do? We can do some calculations with this one. Okay, let's do that. Let's print out it.
Bala, it's getting blurred and then it's getting clear. It's getting blurred, you know.
Is
all
it?
the time.
Okay, 1 second. Just. There's absolutely anything there. I'm sitting right next to router as well. I don't know why. What else? Am I running anything here? No, nothing.
Yeah, now it looks clear. Now
But yeah,
looks
it goes in and out. You're saying, is that?
Maybe someone's using the tablet over Wi-Fi.
No.
No.
clear. See, it's again blurred.
Yeah, is that okay? 1 second.
Yeah.
Just go to the hall itself. How is it now? Is it better?
Yeah, it looks okay.
Okay. If it goes blurry again, just let me know. Okay. Okay. Sorry for that, guys. Okay. Then I'm just going to print out the last one. Okay. Okay. Okay, now let's see. Okay, so what I've done here is, okay, it's pretty simple program. Okay, I'm going to square the different values whatever I got. Okay, first I got an integer. This is next int. I'm going to store in variable called as ival. I'm squaring it. That's it. Next is a float. Again, I'm just squaring it. Again, it's a double. I'm just squaring it. And then for this alone, like, no, I'm going to give a float value, and I'm going to print out whatever is getting stored in integer. Okay. Now let's run this program. Okay. First it is asking for an integer. Let me type something like what we know. Okay, 4. Enter. Next is asking for a float. If I do 4.3. Let's do 6.5, something like that. Okay, it's asking for a double. I'll just give some big number. Okay, now it is going to ask for a integer. Oh, sorry, now I need to give a float here. Okay, 9.2 something. Okay, let's see what's printed. You see this one, right? Now it's pretty simple. Okay, so whatever, when I give 4, right, 4 got squared and then 16, and then 6.5 got squared and it's 42.5. And then this big number got squared, and then it's e to the power 8. Okay, so it's just not 5.42. Okay, it's 542 blah 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 8 digits, and then the dot arises. Okay, and the typecasting is pretty simple. What we know, when we try to store the float into the integer, right, 9.2 will get rounded off as 9. Okay, just the decimal part will be dropped. That's it. As pretty simple as this. Okay, I'm going to leave this program, okay, as it is, and then you can use it to do the exercise, okay, to get the input from the user. Okay, I'm going to talk about a string also. Okay, what is string? Okay, now this is in our last session, right? Okay. We saw different type of data types last time, right? We saw integer, we saw float, double, and then we saw character. Okay, one of the most important thing what we will regularly use as a variable, right, it's called string. Okay, it's not a primitive data type. Okay, it's a class actually. All the things whatever you saw, right, int, float, everything all had a fixed size to it. Okay, as I explained in the last class, right, int had two bytes, float had 4 bytes, int had 4 bytes, float had 4 bytes, long had 8 bytes, and then byte has got single byte, short has got 2 bytes, like that. But string, right, string doesn't have any predefined size allocated to it. Okay, whenever you however length of your string, right, it will dynamically get allocated. Okay, so you can store you can store a single character in it, you can store a big sentence, you can store a whole essay in a single string object. It doesn't matter about the size. Okay, string is nothing but a collection of characters. That's it. Okay, so again, first you do the data, like how you do int e is equal to 5, right? The same way how you do is string any variable name, and then in the last class itself I told you guys, right, when you want to represent a character it should be in single quotes, when you want to represent a string it should be in double quotes. That's it. Okay, so apart from this academic sessions, right, in my programming I have never really used characters as individual. I always use string actually, because let's be honest, okay, in our day-to-day thing, right, we never deal with character. You never say A, B, C, or D. You always use a collection of characters, and you always use a word or a string, okay, together. So string is the most common thing which you will use. Okay, so string you can say anything. Okay, game, and then what else? You can just type anything like this. Okay, and then you can do you can treat it as exactly as any type of any variable. You can just print it, and then it will just print out. So you know it's going to print out the other one. Stop. Okay. Okay, it's just going to print out the same thing. Okay, that's it. There's nothing big to it, string. Okay, but you will be using it more common. Once we saw class as an object, right, we'll see more into what is string and what are the additional functions available inside the string, how we can manipulate it, all those things we will see. So as of now, right, just remember string is another data type which you can use it to store collection of characters. Okay, that's it. Nothing much to. Okay, now I'm just going to rename this one. Okay, where is refactor? Okay, And then now what I'm going to do is like now I'm going to talk about scopes, what is scopes and how it is used. Okay, just going to, okay, again. Okay, so when you define a, say for example, when you define a variable, right, interim I is equal to 5 means right now this is a variable. Okay, when you usually do a program, right, there will be lines and lines of codes here. Okay, there will be multiple lines of codes. Okay, so what is this? What is scope means right now? For how long this? For how many number of lines, or how long this variable, right, is available to be get accessed? That's what really scope means. When I say scope means right now, what I mean is right now, you see this one, right? This is whatever you type inside this one, inside this flower bracket, right? They are called block of code. That's what really scope means. Okay, so you can have any number of blocks inside a block itself. You can have like I can do a double quote. I can do double quotes here again, and then I can do a double quotes again here. Okay, now what this means is, let's do this. Int j is equal to 5 6, int k is equal to 6 7. Okay, so now what has happened is like now so this block of code is inside this scope. Okay, now this block of code is inside this scope. When I say scope means like no, it's just a start of the flower bracket and end of the flower bracket. Okay, that's it. Nothing big to it. Okay, so whatever is outside of this scope, right, that is available inside, you can access it inside this block also. But whatever is available inside this one, right, you can't access it outside. Let me explain to you what do you mean by that. What I mean by that. Okay, you have declared a variable called as j, right? It starts existing from here. It will end once a block of code ends, right? Once you see the flower bracket, right? The scope of j ends there itself. Let me name it something else. First, second, third. Okay. Now you can have codes here. Okay. Yes. Second. Yes, out. First. Okay, so what has happened here is so the first is available inside this block. Okay, because it is this variable, right, this member, right, this member is available outside this block. So whatever is available outside, right, it is available inside also. Whatever available inside this block, right, won't be available outside. What it means is like now, so when you create a variable, right, it starts existing immediately in the memory. Once the block of code, right, once the scope of this variable ends, right, you can't access it anymore. So when you do the end of the flower bracket, right, that's it. The scope of that variable ends there also. Okay, so the second ends it here, and the third starts existing from here and ends here as well. So you can't access it here. If you type if I put third here, right, it won't exist. Okay, it will start complaining. Because it will say that it cannot resolve the symbol. It doesn't know what third means. Okay, if you type it here, right, it is available. That's what really scope means. Why I wanted to tell you this one, right? You see this, right? So everywhere scope will be there. Without the scope, without the flower bracket, at the end of the flower bracket, right, that defines a block of code. Without defining a block of code, right, you won't have any Java program itself. Our Java program itself is blocks and blocks of codes only. So how you will define a block of code, right? It will be a start of the flower bracket and end of the flower bracket. Okay. It's pretty simple concept. Whatever you define inside that one, right, it is available only inside. Okay, it can't exist outside. So that's what it really means. So if this is called global variable. Okay, we'll be seeing that later on. Okay, simply you can just name this global. Okay, you see this one, right? This will available here. Actually, you can access something. Oh, it should be static. Okay. Sorry. Okay, so it will be available. So you see here, right? This is available outside this block, so you are able to access this one. Okay, so this first character, right, that is available outside this block, so you are able to access it inside, and then you can once this block ends, right, you can still access first. Okay, I can do. It's a perfectly valid one, but you can't do this one. Okay. If I try to access second, right, there won't, it will say cannot resolve symbol, because the reason is like, now second has started existing here and it has ended here itself. Okay, outside the block of outside this block of code, right, you can't access second. The scope, if someone asks you, if someone draws this one and asks you to define, okay, what is the scope of the second, means like, no, you should say like, it starts existing here and then, sorry, it starts existing here and then ends existing here till here, right, you can access this one. Okay, if you do this, right, it will work perfectly, because it is still the second, this variable is still available. This variable still exists in the memory. Once you come outside of scope, right, this variable stops existing. You can't access this anymore. So that's what the scope means. That's what the block of code means actually. Okay, so the reason why I told you is like, because we are going to see the looping statements, and then we are going to see the if statement and the condition statements in this class, in the next session. In those statements, right, everything will be followed with the block of code. So whatever you do inside the block of code, inside the block of code, right, it is available only for that piece of code. It can't be available outside of the code actually. Okay, now what I mean by that is like, see, this whole thing is right now, it's a function, right? It's a function. Okay, don't look at it. As I told you right now, this is a block of code. Okay, whatever you're going to type inside, right, it's a block of code. And then whatever variable you create, okay, where one, so for example, if it exists only within this one. If you create another function, right, okay, here you can't access the var one. Okay, because it stops existing here itself. Okay, but if you copy this piece of code inside this block, right, you can access var, because now this is existing inside this block of code. For this block of code, for this block of code, right, var1 is visible. Inside this block, right, you know what var1 is. Okay, so that's all to it. You can have as many sub blocks as you want. Okay, there is no restrictions to it. You can keep going like this. Okay, there is no restrictions at all. But the only thing is like, so here is like, this is the innermost child, right? Whatever available inside is only available here. Okay, whatever available here is available for this child. Whatever is available here is available for these two childs. Whatever is available, it goes on like this. It's like parent and child relation. Okay, so this is a parent block. Okay, this is the first child block. So whatever is available for this parent is available for this child also. So think like this. Okay, whatever is available here is available inside here, so it is available here also. So it goes on like this. So it's like a grandparent, parent, child, like this relation. So child has got access to all the top level things. Okay, but child can't have access to whatever its own inner child. Okay, so that's what scope means. Okay, now is everyone clear with what scope means, what this block of code means? So whenever they talk about block of code, right, it will be always inside a scope. It will be always inside this flower bracket and close bracket. So whenever they talk about scope or block, right, it really means is like, no, it's this flower bracket and the end of the flower bracket. Okay, that's all to it. Nothing much. Is everyone clear what scope means? How the members get access to inside the scope and outside the scope, right? It's pretty simple. It's only so it's like, if it's available in the parent, means the child can access it, but if it's available inside the child, means the parent can't access it. That's it. Okay, now I'm just going to just give a couple of examples here. Okay, now I'll go first. Okay, first is better. Fine. Now let's do this. Yeah, again, you see this one, right? So it's saying the name conflict. Okay, so it's saying that read this statement, right? Variable third is already defined in this scope. What do you mean by that is like, no, so this scope exists here, okay, but there is nothing called third here. But the thing is why it's not allowing, right? It is available in the parent, so it is available for child also, so you can't have a naming conflict like that. But the thing is like, now if you 1 second, I'll just that's this fourth. And then again here also you will see the same thing, because the reason is, even though if it is not available in the immediate parent, but it is available in one of the parents, so it still have access to the third variable here. So you can't have the variable with the same name again. You can't declare two variables with the same name. So that is the reason why it's complaining. Variable third is already defined in this scope. That's why it's coming. So we need to rename it. That's it. Okay. Just going to read. It's pretty simple as this. Okay, it's just a multiplication of everything sequentially. Okay, and then if you go, if you try to access the fifth here, right, it won't be available actually. If I do it, it won't available. But you can have access to, you can access anything whatever is parent. You can access fourth, you can access third, you can access second. You can access everything. So from the fifth, right, in the fifth block, in the fifth inner child, right, you can access only fifth child, whatever is available for that child. In the fourth inner child, you can access all the things that are available for the fourth in the fourth child, and then all the parents as well, parents members as well. But you can access its own child, okay, which happens to be fifth. Okay, so it goes on like this. So in the third, you can access first and second, third, but you can't access fourth and fifth. Goes like this. Sorry. Okay. This is to it. Okay, that's it. Nothing much to the scope. Okay, now please interrupt if you don't understand anything in this one. Okay, whenever I say something. Now, okay, let's see what is relation operators and conditional operators. It's pretty simple. Most of you might know it by this time actually, because everyone has done some programming. Okay. Just kidding. Operators. Okay. Okay, so when I say operators, right, now last class we saw arithmetic operators, right? Arithmetic operators are multiplication, division, addition, and subtraction, and one more thing called as modulus. Okay, we're going to see something called as conditional operators. So the various types of conditional operators, what you got is like, now one is greater than, I'm just going to less than, and then you got greater, less than, equal to, greater than, equal to, and then you got something called as we'll do the bitwise later. Okay, that's it actually. These are the only conditional operators available for you. Okay, as simple as that. Okay, and then we are going to see something on the if statement as well. Okay, so if statement is called as conditional statement. The reason why it's called if else, okay, why it's called conditional is like, now you want to compare two statement, you want to compare two items, and then based on the comparison, right, you want to make a decision. That's what the if is basically for. And if the condition satisfies, right, if the condition is true, means, if the condition is met, means you execute a block of code. If the condition it's not met, means you will execute another part of the code, another block of code. Okay, so let's just jump into it. Okay, if statement starts with just if, and then inside this, right, you just need to give your own condition, what condition you want. Okay, now let's do some simple thing. Okay, let's see if it's 4 is greater than 3. Okay, 4 is always definitely greater than 3. Okay, now let's see. Okay, if you do else here, right? Okay, yeah. If you have worked in testing before, you will know what is unreachable code means. Actually, this is one of the good example for unreachable code. Okay, so what this means is like this is one of the bug actually when you do the testing, right? So when you do a testing at the unit level, right? What you will be looking for is like unreachable codes. So what is mean by unreachable code right now? This condition is if there is a statement which will never get executed, that's basically what it means unreachable code. Why it is unreachable code is right now, so 4 is always going to be greater than 3. Nowhere in this universe 4 will become less than 3. So always this condition will be true. Okay, this condition will never become false. So if the condition will be always be true means like only this part of the code will be executed. At no circumstance in the life cycle of this program, right, this piece of code will get executed. That's why it's called as unreachable code. Okay, that's all to it. Okay, now if I execute it, right, I just need to rerun it, I think. Yeah, if I run it, right, yes, we know 4 is greater than 3. Okay, let's do it in a bit of a different way. Okay, let's get some values dynamically. Let me do a different scanner. Okay, now okay, let's execute it. So what I've done here is like now I've asked the user to enter 2 values, and then after that it will wait for the user to enter 2 values. Once both the values are entered, right, I'm just comparing those 2 values. If val1 is greater than val2 means, right, I'm just typing val1 is greater than val2. If the condition is not true means like it obviously means val1 is less than val2. Okay, so it will be less than val2. Now let's enter 2 values. Okay, let's enter first 3 and then 4. Okay, so 3 is less than 4. That's so this part of the code has been executed. The first value what I entered, right, that is less than the val2. Now let's do this one. Okay, let's give both the things same values. What will happen? So, if I give 3 and then 3 means like see 3 is less than 3. So what happened here is like so it will compare whether 3 is greater than 3. No, 3 is not greater than 3. 3 is equal to 3. Okay, so it won't it means that its condition is not true, so it will always execute the second one. Okay, now to take care of that also, right, now what you can do is like if you want to do both means like you can just do this one greater than or equal to, and then here you can do this one also greater than or equal to. You type this, right, the statement will be true now. Okay, if I enter 3 means like it will say 3 is greater than or equal to 3. That's correct only. And then if I execute it again, right, if I enter 4 and then 3 means again the same thing will get same thing again, and 3 and 4, it's 3. So like this, right, you can have you have different types of things. Okay, what we saw is greater than, right, you can do less than or less than equal to. You can, everything is a valid one. Okay, These are pretty fundamental ones. Okay, let's see some complicated ones. Okay, now let's do this one. Okay, I'm going to leave this one and open a new one. Okay, address part 2. Okay, just name it like this. Okay, so let's first define if statement. Okay, so what I told was like, no, inside the if statement, right, the condition should become true. When I say the condition should become true, right, so if you do 3 is greater than 4 means, like, what happens is right here is, right, 3 is not greater than 4. So the what will even though you have done it here, right, once the Java executes this program, right, this will become it will execute the statement and it will become as false. So that's how the Java will see it, even though you don't see false here, right? When it executes, right, this statement will get the statement will get executed, and then this piece of line will be transformed into what is the true condition of that statement, either true or false. Okay, so you can do in the last session itself we saw what is Boolean, right? Boolean, and then I'll just name it as a B. Okay, so if you do true here means like, no, and if you do B here, right, this is a perfectly valid one. Okay, condition is true. If I run this, condition is true. So it's simple as this, because when it executes this one, right, this B will be converted into something sensible. It's a variable, so the Java will replace it. What is stored inside B, it's true. So it means that if condition is satisfied, it is true. So it needs to execute this block of code. Okay, you can do this one, else part. Condition is false, and if you change this one to false, right, next part will get executed. The second part will get executed, because once it changes this to false, right, this condition is not true. This block of code won't execute it. The else part will always get executed. Okay, that's what all to it. Okay, now in the last program what we saw was, right, we are comparing two variables, right? You can compare it and then store I'll show it to you how it works. Okay, I have given directly false here, right? You can do like this here. Okay, if 3 is greater than 4, this is a perfectly valid statement. And if I print out S out, right, if I print out B, right, what will happen is it's going to print out false for me as the first one, because 3 is not greater than 4, so the condition is false. Okay, so it has stored as false. We know in the Boolean only you can store either false or greater than or true or false. Only in Boolean you can store only true or false. Okay, so that's all happened here. So we can copy this program here. Whatever we have done here, you can just manipulate it a little bit. Now what we have done here is, we have done the comparison here, right? Let's save that comparison inside a Boolean variable and then do it. Okay, we can do it like this. Okay, we'll call it as flag val1 is greater than val2, and let's do that. All right. Okay, this is a perfectly the same. It's exactly the same thing. Just you are comparing it earlier and storing the result in a variable, and then using that variable to decide what is going to be the condition of the if. Okay, if I execute this, right, it's going to exactly execute as the same one before. We just need to enter through values. So 3 is less than 4. See, it's exactly the same thing. Okay, now earlier itself what I told. Okay, let's do this one. Okay, let's take out and then now If I do this, right, it's going to say that 3 is not 3 is less than 3. The reason is like, no, it's exactly the same thing. Okay, whatever you can whatever condition you have done, right, that will get executed and the result is getting stored in the flag. Okay, in this boolean variable. That's all to it. Okay, so whatever you have put in the statement, right, it will get executed and then it will be replaced with the boolean flag, whatever the boolean variable. Okay, you can't have the int variable here. If I type val1, right, it's going to throw an error to me because it is inside the if statement, right, you can have only boolean variables. Okay, you can't have integer because integer can with integer value, like now if you enter 3 means, like now if 3 means, there's no sense to it. It doesn't know what 3 means. Okay, inside the if statement, right, it can have only 2 things, either true or false. Okay, what can hold true or false is only boolean. So it will accept one if statement, right, it will accept only boolean inside in it because it has to make a decision based on whatever has been resolved inside this two brackets. Okay, now I can do this as simple as this. Okay, now what are the variables we saw? Okay, let me type that one. Okay, operators. Okay, okay. This okay, like this. Now it's simple as this one. Okay, now let's do one thing. Okay, so what we have done is, here we have seen whether it is greater than or equal to. Now if you want to see whether if it's equal to or if it's both the values are, so we have got only 2 comparisons. We can only know if it's greater than or equal to or else less than. Okay, if you want to know exactly three different items, whether it is greater or whether it is equal, whether it is less, means, right, no, you can have something called as nested if statements. Nested if statement is nothing but just if. I'll show you how it works. Okay, so now you got a else part, right? You can have a condition statement here also. If you want a condition statement here, means, right, no, all you have to do is, press if here and then you can have another condition here. Okay, now to now what we have done is, right now, let me, okay, let's have it like this itself. Okay, so when I enter 2 values, right, so it will first compare, but it will check whether the val1 is greater than val2. It will store it, whether if it's greater than, means, like, no, it will store it here. It will print out this block and that's the end of it. None of the else part will get executed. Okay, now if you okay, if the val1 is not greater than means, like, no, say for example if your val1 is equal to each other, means, so what will happen is, I'll do it this way. Okay, it will be much easier for you guys to understand and then we will see what okay, now first what will happen is, val1 will get compared to val2. Okay, whatever result will be get stored here. So if you for example if you give 3 and then if you give 4 here, means, so obviously 3 is not greater than 4, so you will have false here. It will come to this else part. This block of code will get executed. Now if this if statement will get executed. Now val1 will be compared against val2. Is it 3 is equal to 4? No, it's not equal to 4. So this else part will get executed. Now what it means is, like, no, it will, sorry, Okay, it means that val1 is lesser than val2. Now if you enter 3 3 means right now obviously this will be false, it will come here, it will 3 3 will become equal to, it is equal to each other, so it will print out val1 is equal to val2. Okay, now if I execute this one, right, if I do 3, if I do 4, 3 is lesser than 4, run it again, if I give 4, if I give 4, 4 is equal to 4, that's how to, okay, nothing. I give 5 and 4, 5 is greater than 4. Okay, simple as this. This is called nested if statement. You can have any number of ifs, anything you want. All you have to keep in mind is right now, this if statement has got nothing to do with this if statement. Okay, because this if statement belongs to this else block. Okay, this if statement will only this if else will get only executed if it comes inside this else block. Okay, so you can have any number of nested. You can have, again, you can go like, keep on going like this. Okay, if you can have, you can keep on going, you can have as many nested statements you want. This word they call as nested statement. When I say nested means like, no, one if is inside another if. That's what they usually call, that's the programming term they use, nested if statements, so nested conditional statements. You can go as many nests you want. Okay, as many inner blocks you want, it's not a problem. Okay, it perfectly the logic works exactly as we just saw. Okay, so in the first, when I started, right, what I just did was like, now you don't need to go like this is a proper way and clear way of doing it. One shortcut method is you can just type, you don't need this block. Okay, you can just, by default, you can say just like this. Okay, you can just else if they call else if. Okay, this is how they will this is how they will do in the real-time programming. Okay, because this just increases, it's exactly same as this one, it's just number of lines of code will get increased. Okay, so that's why to solve that one they just do this. Okay, that's it. Now what happens is, this, yeah, one second, sorry. Now, okay, first what happens is like, now first if this state, so I will put this one directly here. Okay. Now first val1 will be compared against val2. If it's greater, that means it will execute it here. Next it will execute this else. That else has got a condition. So again, if it will check whether both are equal to each other, then if it's equal to means it will print equal to. Again, if it's not equal to, it will come to the else part, it will print this one. Okay, this is called as nested if statements. Okay, now we saw basic conditional operators, right? I'll just put okay, so we got something called as logical operators. What is logical operators means right now? There's basically only two things which will I think three things which will majorly use. Okay, operators. Okay, so first one is negation, another is ampersand and operation, another is or operation. That's it. Okay, now what this means is like, now this logical operators means like, if anyone if you've done electricals, right, you will know what is AND operation means. AND operation means like, now if you have true and then if both the sides, if you have true means no, very good, it's not worth typing it. I'll just show you the thing. Okay, plus okay, if so this is the AND operation. Okay, so if okay, if both are false means you get false, false and true means you will get false. If any one of the one side is false means you will definitely get false. To get true, right, both should be true. That's called AND operation. And in OR operation, right, it's other way around. It should be both should be false to get a false. If any one is true means it will become as true. Okay, That's not it. There is something called XOR operation also, which I use it sometimes, but not often. Okay, XOR is very simple. If you get both true, both true or both false means like you will get false. Okay, so 0 0 means it's 0, 1 1 means it's 0. If both are different from each other, right, you will get true. Okay, that's all XOR operations. I think it's pretty, and an OR is pretty simple. Okay, not is nothing but it's just a negation of something. Okay, so whatever you give, right, it's not an operator, because you are not doing it on two variables. You are doing it on a single variable. So if you do negation means like 0 means 1, 1 means 0. That's all to it. Okay, and operations. Because the reason why you got an AND operation is, right, so here it's pretty simple. You just need you got only one condition statement you need to execute, but in in pretty much most of the circumstances, right, you will have multiple conditions to compare with each other. So when you want multiple conditions, right, you just need to go like that. Okay, now let's see this one. Okay, let's do simple thing. Okay, now we got okay, I don't want to disturb this. Let me create another one. And we are going to see something called as a bitwise operator also, which will be pretty useful actually. Okay, again I'm going to do something. Okay. What are the thing I'm going to do here is, going to do some logical operators, right? Okay. Now I'm going to get one value from the user. Next time. Okay. Now, so So if I run this, right? Okay. Come on. Okay. So if I give a value 6, right? So 6 is between 5 and 10. So what I've done here is, right now, the logical operator means, right now, first it will execute this one. This will become what this. Oh, sorry, let me copy this one. Okay. Okay. Now, what will happen is, right now, this part of the first condition will get executed. Okay. When I gave value 6, value as 6, right? First condition will get executed and it will become true. Okay, and then the second second condition, so because it's ampersand, right, it will first condition has become true. It will try to execute the second condition also. So when you execute the second condition, right, what will happen again? 6 is again less than 10, right? So again it will become as true. So true has happened. So but if you enter, say for example 4 means, right now, again what it will do is, right now, whether val1 is greater than 5, no, it's not greater than 5, it is false. Okay, now it will never execute the second part of the statement. The reason why the Java won't need to execute the second part of the statement, right? Because it happens to be an ampersand operation, it just needs to execute the first statement. If once it executes the first statement and it gets result as false, right, it doesn't need to execute the second statement, because even after, it doesn't matter whatever the result of the second statement is, it's all, the whole result is always going to be false, because an ampersand operation, right, if one is false means the whole thing will always result in false. That's why it will never execute the second part of the statement. Okay, let's see this one. Okay, now say for example, now what I've done here is, right, now whatever value you give here, right, it will just increment that value and then compare against 5. Okay, so if I execute this one, right, just put a value here. Okay, now if I give 2 means, right, I'll get 3 here. Okay, now 1 second. Yeah, okay, so now let me give something in between. Okay, so first let me explain that one and then, yeah. Okay. If I give 6, right, I'll get as 8. The reason why I got 8 is, right, now first it will compare the 6 again. Okay, so first it will execute this statement. Okay, so in this bracket wise, right, whatever is the innermost thing will get executed first it will execute this one. Okay, so what I have entered is 6. Okay, and then we know what this plus operator means. It will just increment by 1. So 6 will become a 7, and 7 is obviously greater than 5. Okay, now this condition has become true. Okay, now again this will get executed. So 7 will be incremented again. So which will become as 8, and 8 is still less than 10. Okay, so this part also got executed now. And then it is less than 10, so this will get printed. Now what has happened is, whatever value you entered, right, it got incremented twice, so that's why you got as 8. Now if you give anything, so what I told you in the ampersand operation, right, if this condition is not true means, right, now this will never get executed, right? That's what I told you, right? So if I run this one and give like 4 means, right, now it will get executed only once, because the reason is, like, now it will execute this one 4 will become incremented by 1, which will become as 5. And is 5 is greater than 5? No, it's not, because 5 is equal to 5. So it will never get, so this statement will become as false. And then because of AND operation, right, it will never execute the second part, because the Java knows that one part becomes false means, or it doesn't matter what the results of other parts, it will always, the total result will be false. So it will never execute the second part, and then it will just end there. The statement, or the whole condition will become false here itself, and then it won't execute it. It will execute the else part. Okay, that's how Java works. Okay, this is the ampersand operation. The same thing goes for the AND operation as well. Okay, if I do AND operation, right, OR operation, right, if I execute this one, the reverse thing is true. Okay, if the condition becomes true here means, right, now it won't execute the second part, because Java knows that in OR operation, if one statement becomes true means it doesn't need to execute the second statement, because the whole thing will always result in true. Okay, so if I give anything less than 5 means, right, say for example 4, it will get incremented twice. Okay, now if I give anything greater than 5, it will get incremented only once. Okay, the reason is, like, now here itself the condition has become true. Okay, now what has happened is, so when I give 6, right, so 6 will be getting incremented by 2 times, which is 7, and then 7 is compared against 5, and then that's it. The statement has become true here. That's it. It won't execute the second part. But when I give 4, right, why it is coming as 6, right? Why it's coming as 6 is because 4 has got incremented here, which will be 5, and then 5 is greater than 5. No, it's not. So it will execute. So this statement is false. So it will execute the second part. Okay, because think like this: if it's an AND operation, right, Java will search for a false, because false has got power over truths. Okay, in the AND operation. Okay, in AND operation, right? 0 is the most false is the powerful one. So once it gets false, right? That's it. It will stop executing there, and that's the end of it. And the reverse is true for the OR operation. True is the most powerful thing. Okay, true will override the false one. Okay, so it will execute each block, and then it will execute each block until it gets true. Once it gets true, right? It will stop execution there, and then it will finish the condition statement there. Okay. Now that's all to it. Okay, OR operation. I just wanted to, because this might look a bit complicated, but I just wanted to show you guys that it will stop executing there. That's why I wanted to show you guys this one. Okay, now let's remove this complicated one, and then let's go back to our original this one. Okay, simple ampersand operations. Okay, now is one more thing. I have to and then again you can have any combinations you want. Okay, you can have any combinations you want. You can have like this. I'm just doing. There's no logic here. I'm just doing to show you. You can go as many numbers you want. Okay. You can go anytime you want. Okay, any number of cases you want. Okay. Now what they will say is like, no, this is not a very good way of programming if you do like this. So what they will say is like, no, because it is very hard to understand this one. Okay, you got both ampersand and OR operation here. Okay, so what they will suggest to you is you can have multiple operation conditional logical operators here, but the only thing is like, no, you just need to define the scope properly. You just need to brace it. Okay, so what I told you in the starting is like, no, the innermost bracket will get executed first. Okay, let's do this one. Okay, let's give space between each other. Okay, now in this one, right, what is the innermost? So this is first, it will come here, and then there is another brace here, and then this is the innermost thing. Okay, first this will get executed, then this will get executed. Okay, because it has got this is the first inner part. Okay, so first this operation will get executed. Okay, whether it can result in true or false, then it will compare against this one. Okay, that's how the multiple logical operators work. Okay, you can have as many numbers of one, but just define it inside a scope. Okay, inside a brace. That's the most important thing. So what I mean by that is, right now, if we do that here, if I just remove this. Okay, so in the previous thing, what I'm trying to do is like, now, so I'm just comparing true. This is what will happen. Okay, here first this will be compared with each other, and the result will be formed. Say for example, it's a true. Okay, and then next this will be compared against each other, and then the result will be formed. First this one. Okay, and then this will be compared against each other, and then a result will be formed. Say for example, it is false, means like, no, first these two will execute it. What is true and operation of true and true, which is true. Okay, so next it will become as just true or false. Okay, now what is the result of this one? OR operation means like, no, true get precedence over everything, so the result will be true. Okay, that's how it works. So if you put a false here, right, now this will become as false, both will become as false, and then it will result in false. Okay, so first this innermost statement gets executed first, then the result of that one, right, will compare against this one. Okay, you can have as many number of braces you want actually. Okay, you can keep going like this, but what they will say is like, nah, if you keep going this, again, it becomes too complicated. So whenever the good programming is like, now, whenever you want to go more than twice, means like, no, you need to break it into a separate if statement. So that's what they say actually. Okay, so if you're doing like this, means like, no, so you usually won't have like this. Okay, so what they're trying to say is like, now, if you have more than two, means like, now, just break this down. Okay, and then put it here. You need to use a logic, but put it here. Okay, so value is greater than 1, something like this. Okay, where it's comparing this place. space. Just we have extra space here. Okay, that's all. Okay, just break it so that like no, it is easily readable and then easily maintainable. It will look very fancy to do it in a single statement. Okay, but use your logic and try to break it down. Always try to follow in a single step. If it's really required, you use a third logical operator in a single if statement. You can have 4, 5, anything, but anything more than one is like no, it's not very good programming. You need to break it down. Okay, you need to break it down into multiple ones so that like no, it's easily maintainable. Someone sees other person sees your code, right? They can understand what you have written, because it's really hard to interpret if you have multiple logical operators in a single line itself. Okay, so that's all logical operators means. Okay, so what we saw is and and or, right? There is one very important thing called as negation as well. Negation is really simple one. Okay, now if I remove all these things, right? Negation, what the symbol is? It's just this is the negation symbol. Exclamation is the negation symbol. Okay, so if you put the exclamation here, right? Just remove this. Okay, so what this? Okay, so that's it. Okay, all you have done is like now whatever results you get, right, you are just negating it. Okay, now so what is val1? I've given 3. Okay, what is 4? Sorry, val2 is 4. Okay, is 3 greater than 4? No, it's not. So the result of this one will be false. Okay, the negation, what will do? Negation is 0 will become 1, 1 will become 0. So false will become as true. So this whole condition result will true. So instead this block will get executed. Okay. So you remember in the past program we had greater than here, we have got smaller here, the same thing, because the reason now why I've changed it again, because I've done the negation, right? So negation means false will become true, true will become false. Okay, so if this results in true means, right, that will become as false, so and then else part will get executed. So if the val1 is really greater than val2 means, right, no, it will result in true, but the negation will negate it false. So this if statement will become as false, so the else part will get executed, so this bit will get executed. Okay, that's all to it. It's really simple what the negation is. Okay, now we talked about and an or operation, right? There is something called as bitwise operator as well. It's really useful thing actually. Okay, when you do logical programming. Okay, I'll tell you what is bitwise. Okay, so when I say these are all logical operators. Okay, now when I say bitwise operators, right, you just need and we saw one more thing called as XOR, right? Okay, so what is bitwise is like, no, it's the same thing. Okay, but you are doing it to a variable. You are going to do it to a variable. Okay, I will do a separate program and then I'll show you guys. Okay. Just copy this. Now, so int I equal to if you have 1 means, right, now which j is equal to, what you can do is j is equal to 2. Okay, now is equal to so what will happen is like, now this result will be 3 if you print it. Okay. Oh yeah, sorry, of course it's 0. If it's or means it's 3, sorry. Yeah, okay. So what has happened is like, now what is I means in the binary format, So say for example 1 means like, no, what's the binary of 1 is, we will represent in a byte, okay, 0 0 0, sorry, 0 0 0 0 1, okay, and 2 means 0 0 0 0 0 1 0, okay. Now if you do AND operation on this one, right, what will happen is everything will become a 0, because right, so you got 0 0 0, because 0 0 is 0, and then again you got 0, and again you got, sorry, again you got 0, and then 0 and 1 is also 0, and 0 and 1 and 0 is also 0. That's why for the, if I do the OR operation here, right, sorry, AND operation here, right, I will get the result as 0. If I do OR operation, right, the same thing, it will become 0 0, sorry, 0 0 0 0, again 0 0, because 0 and 0 is 0. So, and in our operation, true is the 1 is the dominant one. So 1, this will become as 1, this will become as 1, and this representation is 3. We know that one. Okay, represent as 0. Okay, let's see what is XOR operation is. Okay, in XOR, what I told you was like, no, if both are same means it will become 0. If they are different from each other, it will become as 1. Okay, again, if they are same means it will become a 0, and then again this is also 0, and then they are different, right, it will become 1, and then again it will become 1, it will become 3. Okay, if you do XOR operation, this is XOR operation, if you do this, right, it will become 3. Okay, let's elaborate this program a bit. Okay, okay, now let's see. Okay, now let's execute this one. Now let's do this one first here. Simply one more example. Let's do this one and then see how the result comes. Okay, let's pick up a value like let's do 13, and then one more column like 7. Okay, so what is 13 representation is, so can go more than 13 actually. Let's do something like 27 and then 32. Okay, to do that I am going to need this help. Okay, so what is 27 is, it's 1 1 0 1 1. Okay, so it's 1 1 1 1. Okay, this is 27. 32 is going to be 1001. Okay, let's see some. Okay, let's do this one. So now I need something. Okay, let's do 53 or something like that. Yeah, okay, this is better. Okay, let's do 53 because I need more ones. Yeah, okay. Okay, so it's 1 1. And then 0 1 0. Okay, so this is what we're going to do. So let's do first AND operation. What's the result is going to be? Okay, so let's put one more space. So okay, now first when you do AND operation, right, 0 becomes 0, 0 0, and then in AND operation again 0 becomes 0, and then again now 1 becomes 1, and then again this is 0 0 0, and then this is 1. Okay, because both are 1, because 0 false is a dominant one. Okay, in the OR operation again 1 is a dominant one, so this will become 1 1 1 1 pretty much everything is 1. Okay, in the XOR operation, what will happen is right now, if it's same means it will become 0, if it's opposite each other means it will become 1. Okay, so this will become 1, this will remain as 0, this will become 1, this will become 1, this will become 1, and this will become as 0. Okay, now what is this value is right now? It's 8, 16, 17. Okay, because I know that, so it's 17. Okay, it is 17, so it's 1 0 0 1. Okay, that's what you got. So you got all the ones, right? So I think that is 16. Sorry, it's 15, and then you got 16 here. So that's 31. 31 plus, I think it's 63. I think if I type 63, right? So yeah, that's 63. Okay, so you got 2 zeros and 1 1 1 1 1. Okay, so that's 63. And then this one is 32. So how do I do that calculation is like now? Okay, now let's do the single. So this value represents 1. This is 2. This is 4. It goes on like this: 8, 16, 32, 64, 128. Okay, so wherever you see 1, right, you need to take that 1 and then add it with each other. Okay, so how I came up with 63 is like now it's 1 plus 2, so that is 3. So 3 plus 4 is 7. 7 plus 8 is 15. 15 plus 16, I know that this one is 16, right? So 15 plus 16 is 31, and then 31 plus this one is 32. Okay, 31 plus 32 is 63. Okay, let's do the same thing here. This is 0, we can ignore it. So this is 2, 4, 6. You got 6 plus 8 is 14. Again, this is 0. You can ignore it. Oh crap, I forgot what I was doing. This is 2, 4, 6. 6 plus 8 is 14. Okay, you can ignore this one. And this is 32. Okay, so 32 plus 14 is 44. 32. Sorry, 14, right? 46. Okay, now let's confirm it. Okay, 46. Okay, so 10 1110. Okay, so if I give 2753, right, this is the result what I should get. Okay, let's do that one. Okay, when I insert this one. Okay, now what is the value? 2753, right? 2753. See, 1763 46, 1763 46. This all to it, and XOR operations. Okay, and I think negation operator is the weird symbol. I don't even know if it's in the Mac. Yeah, here it is. Okay, so negation, I'll just do. Negation is nothing but flipping the bits, right? So I think that's it. You're going to get weird results here actually. See, it's minus 28. The reason is right now because you remember in the first class I was talking about the flipping of the first most significant bit is used for the sign bit, right? So don't look at the single byte level, because this represents only single byte. What I've told you is right now in the integer, right, there is how many bytes? There is 4 bytes. Okay, so you're looking at a very big value there. Okay, now to explain this negation in a simpler term, right, I'll just do one more thing. Okay, I'll just do a byte. I'm going to do the same 27 53. In the next one, right, for this byte, right, I'm just going to give 1. Okay, if I give 1, right, hang on. Oh sorry, just this 27 53. If you just give 1, right, so you're getting minus 2. The reason is like now, you remember I talked about overflow, right? What would have happened is right now in a single byte, right, how 1 is represented as in a thing, 1 is represented as 0 0 0 0 0 1. Okay, now when you negate it, right, what will happen is, right, all the bits will get flipped. Okay, so negation is negation of 1 represents this, it will become 1 1 1 1 1 1 0. Okay, so what has happened is like now this most significant bit, right, that has become as negative bit. Okay, now I told you there is some the concept called as 2's complement. So the 2's complement is representative of this one is, right, that's -2. Okay, that's why it is. So I just wanted to know this thing exists in the Java world, but I have never used this in my work actually. But you may need it sometime. Just you should, in the back of your mind, all you need to know is like, no, there is something called as negation operator exists in this world. Okay, that's all you need to do. Where it will be really useful is like, no, in the terms of Boolean. Okay, so because now we are talking about the flipping of these bits, right? It will be really nice to do it in the Boolean way. So if you okay, I'm just going to leave this one as it is, and then I'm just going to put another one so that you can use can't. Oh no. Okay, now I'm just going to remove all these things. Okay, design. Okay, in the Boolean world, right, all these operations will be really simple, and I would say, yeah, you can't flip it actually. I think negation will work out. Yeah. Okay, so this all to it. Okay, so true and false is if you do AND operation, it will become false, and then I and J we can say it will become true, and then XOR means it will become true because true and false, and then the negation of I is false. That's it. The real reason why this thing exists, right? Because in the Boolean world, right, you can use this one, or else you can do both ampersand as well. It's both means the same thing, no change at all. Okay, but anything apart from the Boolean, right, you can't use the, so if you go back to our original program, right, you can't do this. It will complain because you can't do the int between the AND operation between the int actually. So if you want to really do the AND operation between two integers, right, you should use only the single representation of the AND operation and single representation OR. So this is what in the programming world, right, ampersand means AND, this pipe operator means it's OR. This I think power off actually. It's called as XOR. Okay, that's all to it. So if you want to do it on a Boolean, right, you can just use AND operation, which is ampersand OR operation or XOR operation. But if you want to do it on anything other than the Boolean, right, you have to use a single representative operator. That's what they call as bitwise operators. Okay, it's as simple as this one. Okay, now this is all the topics I wanted to cover actually. So what are the things what we saw today was, right now it's really simple actually, if you think about it. So we saw first what we saw was like, we saw something called a string, and then we saw one more thing called as how to get inputs directly from the user, and another thing was scope. Okay, those are three things. I'm going to add those things in here. Okay, scope, what we saw scope was, and then we saw relational operators, and then we saw what is conditional operators. So if you know that, yeah, this is called as I think I just did a mistake here. Okay, relational and conditional operators are pretty much same with each other. Okay, and this is called logical operators, and then this is called bitwise operators. Bitwise operator is nothing but just this is a stripped down version of that one. Okay, that's it. And then what we saw was if statement. Okay, if you go into this one, right, there are really nice exercises which you can do. Okay, which will really help. Okay, just try to do these exercises. Okay, if you have any it's all logic. Okay, from here onwards, right now it will really you need to know the syntaxes, and you need to be a bit of a logic as well, so that to do all these programs it will be really interesting to do if you can do all these exercises. Okay, no, sorry, not all. Okay, at least 10 of the exercises. Okay, if you can do, means like if you have free time, right, I'm pretty sure you guys will have. Okay, do pretty much as much as possible. Okay, so that like no, don't think that it's simple as that one, because if you go deep down, right, you may need to use multiple nested if statements, and then in a single if statement itself you need to use multiple logical operators. You'll have those kind of situations down the line. Okay, so try to do, because initial first 10 or 5 will be pretty easy, straightforward, but if you go deeper and deeper, right, exercise, right, it will get a bit complicated and complicated. Okay, so try to do as much as possible. Okay, and in the next session we will see all the looping statements, and then we'll see the functions also. Okay, do anyone have any kind of doubts? Okay, if you have doubts, right, don't think that you need to wait till the session. Okay, ask me anytime you want, and then if you still if you forgot to ask, or if you still, when you're rewatching the session, if you have another doubt, right, just message me. Okay, I will answer pretty quickly. Okay, yeah, that's all I wanted to cover, guys, today. Okay, I will see you guys on Wednesday. Okay then. Yeah,
Thank you.
no problem.
Thank you.
Thank you.
Bye, guys.
Great,
Thank you, Bala.
Bye.
Thanks, Bala. Bye.
Bye.